All right, Chapter 2, Section 6, Families of Functions, Absolute Value, and Graphs. So in this section, we're going to talk about a parent function, and then we're going to talk about a transformation, which means the graph is moving around on the coordinate plane. Up, down, left, right. It could flip upside down. And so let's get started. A parent function is the simplest function with a basic shape. Okay, we call it the parent. When we move it around on the coordinate plane, that's going to be called a transformation of that parent function. A transformation will shift a graph either horizontally, which means left, right, vertically, which means up, down, or both. Now we're going to make a chart and we're going to graph this function here, y is equal to the absolute value of x. And you'll see after we graph it that it does pass the vertical line test, so it is a function. All right, so you should be familiar with making a table of values. I'm going to choose some x values like -4, -2, 0, +2, and +4. Okay, when I substitute these values into the function, I'm going to calculate the y. Y equals the absolute value of x. So, absolute value of -4 is 4. Absolute value of -2 is 2. Absolute value of 0 is 0. Absolute value of +2 is +2. Absolute value of +4 is +4. Now I have these ordered pairs that I can graph. You see, my table is really sets of ordered pairs. Okay, -4, 4. So I'm going to plot these on this coordinate plane. X is -4, y is +4. X is -2, y is +2. 0, 0. X is +2, y is +2. X is +4, y is +4. It makes this V-shaped graph. I'm going to connect them, these points, and I'm going to draw my graph. Of course, I have to include arrows because this graph keeps going indefinitely in the direction of the arrows. So the absolute value function is a V-shaped graph, like V for value. Okay, now this is the parent function, and it would probably benefit you just to memorize the points on the parent function. They're really quite easy. It's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And then on the negative side, it's just -1, 1, -2, 2, -3, 3, -4, 4. Okay, so if you just memorize those points, you can graph the parent function quite easily. All right, what does the rest of the section say? Well, move the note sheet up here. Graphing absolute value functions by translating vertically and horizontally. So my parent function is y equals the absolute value of x. What happens to the graph if the equation changes like these? Well, when I've got something like y equals the absolute value of x plus 4, that means I'm taking the V-shaped graph, the absolute value, and I'm shifting it up 4 units. So this moves up 4 units. Okay, and what type of translation is this? Well, this is a vertical shift because I'm moving it up. You see, going up or down would be a vertical shifting. This one, absolute value of x subtract 1. Well, this is going to move it down instead of up. And not 4 units, but 1 unit. Okay, moves down 1 unit. Again, that's still a vertical shift. What if my equation was the absolute value of x minus 2? Notice this time, whatever I'm adding or subtracting is inside the bars with x, and it wasn't here. So this is going to move left or right, but not in the direction of the sign, in the direction opposite the sign. So it's not going to move left. This one's going to move right. Moves to the right 2 units. And this is a horizontal shift. I'm not sure if you did this in Algebra 1 or not. Okay, and again, this is grouped in here with x. And so what's going to happen is, instead of moving in the positive direction, it's going to move in the negative direction. So this is going to actually move left. This moves left 3 units. And once more, this is a horizontal shift of my graph of the absolute value parent function. Now, you need to graph the parent function for each one of these in your homework. So you should have 2 graphs. I want you to get used to what the ordered pairs are for the parent function. So we're going to graph this, but first we're going to graph the parent function. All right, I'm going to do the parent function, I guess, in pink. Okay, the points for the parent function are 0, 0, 1, 1, 2, 2, 3, 3. It's just on the diagonal. And then on the other side diagonal, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5, and so on. Okay. So that is the parent function. Now, this, I've got 2 translations going on. Okay. This right here means, look, when it's inside with x, you move on the x-axis left or right, not in the direction of the sign, in the direction opposite the sign. So this is a left movement by 1 unit. When it's not grouped in with x, that means move on y. The y-axis is up, down. So I'm going to move in the actual direction of the sign, down 3 units. Okay, so every point on this parent function graph is going to be moved left 1 and down 3. So I'm going to say this is moving left 1 and down 1, 2, 3, put a dot there. Now, once I have this 0, 0 point, if you will, moved, nothing else has changed. We didn't talk about stretching or shrinking yet. So because there's no stretch or shrink, I know that my points would be on these diagonals. Now, we can check to see if, in fact, this point, where's my little pencil? All right, I'll use this. If this point moved left 1 and down 1, 2, 3, sure, there it is. This point, left 1 and down 1, 2, 3, there it is. Okay, so it works. You could also, to convince yourself, if you weren't quite sure that this worked, you could, choose this point right here, for instance. This point is 0, negative 2. 0, negative 2. So if I put a 0 in here for x, right, 0 plus 1 is 1, absolute value of 1 is 1, plus negative 3 is negative 2. It does work. Okay, but this is just a quicker and more swift way to graph if you understand what's going on with the function's equation. Okay, when it's grouped in with x, we move left-right on the x-axis in the direction opposite the sign. And then when it's not grouped in with x, that's a y-axis movement, a vertical movement up and or down. Okay, and in this case, down because it's negative. So if you have questions on that, post a comment on the discussion board or ask a question in class. All right, we've got 6 graphs on side 2 that we're going to move through. I'm hoping to move through them fairly quickly. I am going to graph the parent function for each one of these. So here's my points on the diagonal. I'm going to do this actually 3 times for now for these 3. And then when I move the paper up, I'll do the other ones. Okay, so I'm just putting dots for the parent function so I know where to move. All right, so I've got my little V-shaped graphs here. On the parent function. Okay, let's look at the first one. Well, look at that. This is the parent function that they're asking me to graph. If I look here, this is the parent function. That's already graphed. So it's already graphed. All right, this one. Y equals the absolute value of x, and then subtract 5. So you tell me, what is your guess? Do I move this thing up, down, left, or right? You say, well, it's not grouped in here with x. It's away from x. So it definitely is a y-axis shift. And it's negative, so we're going to shift 5 units down. So I'm down here, 1, 2, 3, 4, 5. Nothing else is going on. No left, right, no stretching or shrinking. Again, we didn't talk about that yet, but we will in a follow-up lesson. So everything else is just these points on the diagonal. So really, graphing the absolute value function and some transformations of that function, not too terribly difficult. All right, the next one. Y equals the absolute value of x minus 4. Now, look at where your subtraction is with that 4. It's inside the bars with x. And remember, in algebra land, x is tricky. She's sneaky. She's like, oh, I'm going to make them think go left, but really I mean go to the right. Okay, so here we have to move to the right. Okay, this one was move down. All right, so inside with x, move on x, not in the direction of the sign, in the direction opposite the sign. So I'm going to move this thing 4 units to the right. So I go 1, 2, 3, 4. That's this point right here. It's almost like if I could pick this up and just slide it around up, down on that coordinate plane. I'm going to shift it over 4 units to the right. Nothing else is going on. I'm not moving it up or down. It was just a horizontal shift. And no stretching, no shrinking. And I draw my graph. Okay, for these graphs, you need to have more than just 3 points, okay? You can't have just 3 points. You're going to need at least 5 points on an absolute value. So you want to stretch this out. So keep that in mind when you're taking a test or a quiz. All right, the next one. Y is equal to the absolute value of x plus 3. Again, we're not grouped with x, so we're not moving on. This is moving up 3. This one, what's your guess? My guess is this is moving either left or right. It's plus here, which seems like it would be right, but it's not. It's left 6 units. This one, oh, I've got a combination here. This one says move up 2, and this says move to the right 3 units. All right, so I'm going to graph my parent function for all of these. Again, the parent function is not that difficult to graph. I know students are going to ask me on a test or a quiz, do we have to graph the parent function? Yes, 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 graph the parent function, and also graph the parent function in your notes and in your homework. I want to see the parent function. It probably would be beneficial if you had some highlighters or some colored pencils or something to make your graphs of the parent function look nicer. You could differentiate it from the transformed function. Again, you need arrows on the graph. I do take points off if you're not specific with your arrows on the graph. Okay, so there are my 3 graphs of the parent function. Didn't really take that long. I'm going to take this parent function and shift it 3 units up. Everything else is the same. It's those points on the diagonal. So if you get used to graphing the parent function, it's going to be really easy for you to follow along and know what the other points are on the graph of the transformed function. This one here says move it to the left 6. I'm starting here at 0, 0. So I have to go over here 6 units to the left. There are no other transformations on this function. Okay? None. I'm not moving up, down, and I'm not stretching or shrinking, which again, we will talk about that. A stretch is when the arms of the V get closer together, and a shrink is when they go farther apart. That's all that's going to be. All right, last one. We have to move all these points up 2 and to the right 3. So I'm going to take the 0, 0 and move it up 1, 2, and to the right 1, 2, 3. And now all of my points are just on the diagonal. That's it. Because I already used this part. I don't need to calculate ordered pairs here. I mean, you could pick an ordered pair and substitute the x value in here and see if the y works out. I showed you before that it did, and it will. It does. Okay, so I could check, let's say, this point right here. It's the second point from the vertex, okay? If I move it up 2 and to the right 3, up 1, 2, and to the right 1, 2, 3, there it is. There's that point. And it is the first point away from the vertex, right? Just like this one was. If I choose this one over here, which was the 1, 2 points away from the vertex, and I move that up 2 and to the right 1, 2, 3, there it is. And that is 2 points away from that point right there. Okay? So it does work out. Convince yourself that it does, and convince yourself to do some easier graphing. Again, if you have any questions about this graphing, either ask a question in class or put a comment on the homework discussion so that I can help you out. There is a homework assignment, worksheet practice 2-6. You're going to do 1 through 15. And there's also another small worksheet that I have you do. It's on the calendar. It will be on the calendar and on the agenda for the day. If you're not sure what that is. I don't have it written down on my note sheet here. But that's all we have for now for the absolute value functions. Have a great day.